folks. Today I'd like to talk to you about some modules for working with databases in Raku. I'm Jonathan Worthington. I work at Edument. This is the company that helps fund Crow development and also develops the Comma IDE. And I'm mostly known, and usually at conferences, I'm talking about internalty stuff that I've been doing with Rakudo, with MoreVM, sometimes making things faster or adding new features. Actually, after doing the new dispatch mechanism recently, I've kind of been taking a little bit of a break from core things. I'll get back there. But I've been enjoying Raku as a language user mostly, and that is partly for fun. Raku is quite nice for doing toy languages and compiler hackery, and in my lack of copious free time, I do a bit of that. Also commercially, though, I'm mostly building web applications in Raku, and that's often using Crow. I'm kind of to blame for that to some degree as well. But just about every application I work on with Crow is involving a database. And I wasn't entirely happy with the development experience around that. I'm not really talking about the database drivers or things like that. I think there's some quite nice modules in that area, but more about the overall workflow of having a database and having development environments and tests and things like that. So I made a few modules, and that's what I'd like to share with you today. So there's 5 things that I want to talk about, and while I'm going to talk about these in the context of some Raku modules, I think all of these things are generally, at least mostly advisable, though there's probably some debate on at least one of them. So first of all, I think it's really important to make it easy to get working on a system by just having something to get a local development environment in place. I'm currently being loaned out from Edument to a startup where I'm effectively working as their acting CTO. And one of the things that we really value there is making sure that as we grow and more people come in, they can get going quickly. But I wanted that for my Raku web applications as well, so I can just come back to one and right away get a development environment in place. I wanted some way to automate database changes, to make it easy to have those deployed without having to do manual work, and also hopefully to have some silly mistakes caught early. This one is a little bit controversial, maybe, but one of the things that I've kind of found is that SQL is, maybe unsurprisingly, a pretty good language for querying databases. And sometimes, while there's value in having some layers over that, it's actually quite powerful to just work directly in SQL. But then the question becomes sort of how do you bind that to the programming language you're working with? And I want to talk about one module there, which actually isn't one that I wrote, that has an interesting answer, I think, to that. A common observation I've noticed is that if something is not tested, it's probably broken. That applies to database code too, but how do we test that? And to finish up by talking about how to manage development databases and get them set up and access them and so forth. So make it easy to set up a development environment. So I very recently released a module. It's called a Dev Containerized service. And why did I do this? Well, some things are kind of annoying. So if I have a system and it's using, let's say, Postgres, I say, oh, okay, it uses Postgres. So first of all, I really hope that the version of that I've got installed on my system is compatible enough. And then if I need to go and sort of add a database to that, or a user or whatever, I have to go and look at how to do that, because it's one of those things. I don't do it often enough to remember how to do it, so I always have to go and look something up there. And most systems these days, I guess, take configuration, things like database connection strings through environment variables. It makes it easy to do containerized deployment, but also to have them fed in during development. So then somehow those need to get fed in as well, maybe some script. And then I have a few different machines I work on, and then I realized like, oh, I'm gonna have to do all of this again. Now, it's not always so bad. On at least the company I'm mostly working at the moment, we're using Docker Compose. And when I saw that, when I first joined there, I was like, great, Docker Compose file. And for those who don't know, Docker Compose is a way of specifying a set of different containers, wiring them together, and it's pretty useful. The first thing that happened when I tried to set that system up is I realized that the Docker Compose version that was on my system was too old. But finally got that up. And then, of course, there's questions like, oh, okay, well, this database is inside a container, so how do I actually connect and poke around to debug problems? But that's mostly fine. But still, I kind of had this, well, what if? What if for my simple little Raku services, where we don't have some massive microservices. It's a nice little monolithic application. And what if there was a module that just let me declare what services I need, and it would run the container, normally just one, for Postgres, and then run my application and put the right stuff in the environment. And so I wrote a small tool to do this. So how to use it? Well, start out, just add a dependency. Then create a Raku script. I'm calling my ones devenv.raku. Maybe that's an okay convention. Maybe folks will find nicer ones. And then, and this is something I always do, but if not, make sure that things like database connection details are obtained through the environment. And then here's what goes into that deven.raku. We just use the module and then call the service function, say I want Postgres, I want it at this tag of the Postgres image from the Docker library. And then I get passed a hash of connection information. And for Postgres, that actually gives me the coninfo, which is a nicely formed connection string that I can throw straight into dbpg. But it also gives me all of the individual pieces for the case where those are being injected as separate environment variables. And that is it. Let me show you a demo. So here we are. I've just stubbed a simple crow application. It's called Leftover. It's a system for people to tell their neighbors about leftover food they have or ingredients so they can not go to waste. And I'll build a little bit of this during the talk today. And here you can see that I am just creating a dbpg object and then just doing a simple little query here just to prove that we can connect that database and actually get it to do something. And the environment variable dbConInfo is where the connection info comes from. And then here I have written my development environment file, which is pretty much what I showed you on the slide just a moment ago. So let's try and run this. So I can run this script and I can say run. And then I'm going to use the crow application runner. And yeah, run crow run. So this will obtain, if it needs to, though I already had it, a Postgres container and start it up and put it on a free port and set up the user, the database, and inject those into the environment per the specification here. And you can see it says it works, and that comes from here. So we have got a database set up and ready for us to do stuff with. So with that, I have a Postgres instance running the details injected, but now I need to have some tables in the database so that I can start inserting some data. And how should I go about this? I've been working on a module for a while, actually. This one was not a quick thing. This is something I've been slowly putting together in 3 moments over actually the last few months, and a few hours here and there. And the reason I put this together is because I really found the workflow that I had before it annoying. So I have a few web apps, and I thought, oh, okay, I'll just keep a SQL file with the database schema, and when I change things, I'll tweak it, and then I'll just write the little bit of DDL to apply to the real database, and it won't change often. It's a small, simple project. I'll copyright, and I've done this with a few things, and after a while, I'm just like, I really hate this tedium. And at least for me, the database definition language stuff, it's not really that hard to write. It's just one of those things that I don't really do every day, and so easily forget. And I thought, well, can we do a little bit better? And I already knew from other projects, one in Raku, but mostly elsewhere, that migrations are a nice solution in this space. What's a migration? So a migration is a append-only list of changes to the database. So you start out with one of them, which establishes the basics of the schema. Each time you want to do a change, then we write another migration. And when they are applied together, one after the other, they bring the database up to the current state. And some tools for doing migrations have you write them out in SQL directly. Others provide something on top of that and generate them. And typically, these keep a record in the database of which changes have been applied in the past. And then when you want to bring it up to date, you just take the difference of what was applied, what wasn't applied, and apply the missing pieces. Often for simple small systems, then it's quite convenient if you're just deploying a single instance of them somewhere to have it do the changes at startup. In a situation where there might be many horizontally scaled out instances of it, that can get a little bit annoying to do. They sort of stampede to try and do that. Or when the database gets bigger, maybe the impact on startup time for some changes becomes intolerable. And in those cases, it can be better to run them explicitly. But I normally start out with having it done at application startup. So I just deploy the database and the application, sorry, and then at startup it brings the database up to the version that is current. So what are the options for migrations in Raku? So of course, before I dug into writing my own module, I sort of surveyed the landscape a little bit. So there's already a module, and I've already worked with this one in the past, called DB Migration Simple. This is pretty straightforward. You write out the SQL for what you call the up direction, that is to bring the database to a newer state, and also for the down direction, that is to revert those changes. To be honest, in many cases, I only ever really go up, but it can be useful to have the down functionality too. And these are explicitly written out in SQL there, and you pass a DBI-ish handle to it, and it runs the appropriate bits of SQL and just keeps a table to indicate what it's applied so far. It's pretty simple. It didn't work with DBPG, which I'm normally working with, but it could be made to. And I've used that in one system I worked on a while back. Red doesn't seem to yet have migrations fully implemented. At least that was the best I could tell. But I believe there's a Red talk scheduled after mine, so maybe there's news on that. But for people who are using Red, that's probably going to be a nice solution. Red, by the way, is an object relational mapper for Raku. And then the new kid on the block is DB migration declare. This is the thing that I've been toying with for a while, and actually got used in my first real application just recently. I added it there. Fair warning, it's new. I definitely call this a beta. It's Postgres only, and but I want to talk a little bit about what I've done with that. So migrations are specified in Raku code using a little domain-specific language, which really is just a fancy way of saying a bunch of functions that we call, and they set dynamic variables so that they can gather various bits of information. It's actually the very same strategy that is used in things like the crow router and also in the dev containerized service that I showed earlier. So this is just a migration. You give the name, that's just setup. That's just for documentation purposes and for understanding what's been applied. And then we say, well, create the table skyscrapers. We add a couple of columns, three columns here. One is just an ID, auto incrementing. We say it's the primary key of the table. We then have a name column, which is unique, and then we have the height, and we ask for those to all be not null. So then at some point we might want to add another table or grow this database a little bit. So we can add another migration. So here I'm going to add a countries table. So I can say, okay, create the table countries. That's a relatively boring table. And then we alter the sky. Oh crap! Not the sky sky crappers table. That's not what I wanted. So when I do this and try to apply this, then it will say, oh, actually there's a problem here. So this is not just a DSL that creates or just turns itself into the appropriate SQL to do the changes. As it goes, it builds up a model of the current schema of the database, and then it uses it to validate the various changes that we do. So here it will tell me, oh, you've got a typo there, so that isn't going to work, and then we can fix that and have it applied. So let's again go and have a little bit of a demo. So let me walk through a few of the things that I've just added to my application. This is the migration file. I've just called it migrations.raku. The module supports either having a single file with the migrations, or you can instead have a directory of them, and it will sort the file names in ascending order. So this is the initial setup. I'm just creating some tables. So we'll have different types of food that might be left over. We have some apartments and the apartment number, the owner, and then an offer of food is the food that's on offer, which is done as a foreign key here to the foods table. It's the apartment, which is again a foreign key to the apartments table, the quantity of food, and if someone has claimed it yet. So that's set up here. And then I've added a test case. And the test case goes through the migrations, applies them all one on top of the other, and looks for if there are any problems with them. And this means that I can maybe find out about any problems with my migration nice and early. And this is something that just can go into the test suite. And pretty much this exact code came straight out of the README for the module. I just have to make sure you point it at the correct migrations file or directory here. So I can run that test, and it's passing, and it puts out an OK for each migration that it successfully checks and determines is OK. And then finally, in the startup here for my service, we're here taking the database connection, and then I'm making an instance of the migration applicator. Here I just have to give it a name, and this lets me potentially have different sets of migrations, independent ones, applied to the same database. So for example, if I have some kind of module that I'm using, and it also wants to put some stuff in the database storage, then it could supply its own set of migrations and just put a different schema ID here, and then there won't be any history conflicts between the history of my migrations and that module's. And the module actually does check that when you apply schemas, that there aren't any conflicts. It makes sure that the history hasn't been meddled with or something like that. So I make this instance of the applicator, and then I apply it, and I look at the status and write out how many migrations have been applied there. So let's drop over to the console. We can again use the development environment script, and we can run crow run. And here we go. So up comes the Postgres database, and then the service is started, and it's a fresh database. It says, I've applied one migration, and now we are up and running. So that's my first set of migration, my first migration, sorry, and I sort of sketched it out, but I kind of realized that this is not going to be a terribly great app if it only really supports one building with the apartments. So let's write another migration here. So let's call it add buildings. Okay, and we'll create a new table, buildings, and let's just nab this, and then let's add a column. Let's call it address. That can be a text column, and we expect that to be unique, and we'd like it not to be null. And then let's alter the table, and the table that we'll alter is apartments, and the alteration that we're going to do is we want to add a column, building, which will be an integer, and given we haven't got any data yet in this database, we can just say, it should be null. And then I need to add a foreign key, and the foreign key, actually, let's just save a little bit of time and copy this foreign key here. And of course, it's not that, it's to the table buildings. So here we go. Let's run the tests just to make sure. Oh. Cannot alter non-existent table apartments. That would be a typo. Okay. Let's try it again. Still wrong. Cannot add a foreign key to non-existent column apartment of table apartment. Oh yes. This is what copy paste gets you. Let's try it again. Okay, so now it's happy. And if I go back over here, then the application will be restarted, and you can see that you see this has applied one migration here, and yeah, it did the one up here. Since it's a fresh database each time, if I just bring it up again, then it's, as you'd expect, going to do two migrations. There we are. Okay, so now I have a database set up with a few tables. So as I mentioned, this is a relatively new module, and there's quite a few things that I still want to do with it. One of them is to be able to automatically calculate the down migrations from the up ones. So for now, it only does the up direction. Of course, there's an escape hatch where you can write the SQL out explicitly for what you would like to do if there's not something to do it in there already. One should specify the up and the down. But for the majority of changes which is declared, for example, add this column, then the inverse is relatively predictable. It's drop the column. Supporting a wider range of database features is also something to work on. That's both different kinds of alterations that aren't handled yet, but also features like views and stored procedures. I also have been thinking of it about having a command line interface for it, so it's possible to examine what has been applied so far and perform the application of migrations via that tool, which could be useful for those who want to explicitly apply them. Maybe some kind of comma integration too. There's a lot of different things that we do a level of IDE support for on, ranging from Crow and the template language through to the red ORM and its models, and having something for this could also be nice. And also one of the things about doing migrations that drop stuff or doing down migrations that throw away data is it'd be nice to maybe have some way to say, well, please don't just drop the column, but back up what is in first. And having that kind of configurable data retention on lossy changes could be quite nice. And of course, one can always implement these, but having this as a sort of set of patterns to commonly use to handle these cases could also be desirable. Another example of such a pattern could actually be to say, well, I want to drop this table, but what if someone's using it? So actually, the real modification I want to do is to modify the database to track any usage of the table. And if no usages are recorded in a couple of weeks, then the next time the migration is done, then we can say, we'll complete the action now. So there's a few things like that I have in mind. So let's move on. So I want to talk a little bit about being able to write queries in SQL without having that SQL inlined among the Raku code. And the module for this is called Badger. Why? Well, first of all, let me talk just a little bit about some of the various options in this space. So of course, we can just write SQL mixed up in the Raku code in a here doc or something like that. But stepping back and looking at the problem space and the sorts of things, not just in Raku, but in languages generally that I've seen, object relational mappers are a relatively common choice. I've seen both well-supported and very well thought out ones, and I've also seen ones which were homegrown by individual clients. I don't know why, but that seemed to be something people enjoyed doing. And then they left the company, and people didn't really know what to do with all of that. But ORMs, I mean, there's sort of been a sort of phase of excitement about them and a phase of dumping on them. It strikes me that the problem they're solving is actually just really quite hard. There's not a very neat mapping, I guess, between the relational model and the object model in lots of the non-trivial cases. It's quite easy to sort of get started and to achieve, okay, we have this object that models a row in this table and we can just map between them. That's not so hard. But when we get into more advanced querying requirements, that's where the tricky stuff starts. An alternative to those is things that don't really try to do any mapping of a complex object model onto a complex relational model. They just are ways of generating SQL. And those can have some value. My experience of working with them is that they again maybe make some of the easy things easy. They might be good for database abstraction, but they tend to be less good at making the hard things possible, and you end up reaching for some sort of escape hatches for those. Relatively few projects need database abstraction as well. That is, to work on MySQL and Postgres. It happens sometimes, but the vast majority of the time something is built and it just uses the chosen database forever. So one thing that kind of becomes attractive from all of that is saying, well, we'll just write SQL. But inline SQL in code is ugly, is argued by some, and I don't feel that strongly about it, but I will say that if you have some nice tooling for working with SQL queries and trying them out and so on, and you can't apply it because they're buried in some here doc somewhere in the code, yeah, that could be a bit frustrating, or maybe they clutter things up. So a former colleague of mine pointed out an alternative that I found quite compelling. He said, well, Clojure has this library called HugSQL. Isn't that a cute name? And you write a SQL file, and above the various queries in it, you write comments, and those comments result in functions being declared. So you have something that preprocesses this file and turns it into something that declares functions that run those queries and let you call them just like normal functions in the language. And I thought, oh, that sounds kind of nice. Please, could you do a port of it for Raku? And he did, so thank you. So the idea here is that we just have a SQL file, except it also has comments. And here the comments look like the opening part of a Raku subroutine declaration. And then the SQL becomes effectively the body, or something that calls the SQL becomes the body. This is not just a pure string interpolation here for the parameters. That is done using SQL placeholders, so we don't get SQL injection stuff happening. And that's how it goes. So we write this file, and we have this add skyscraper function. And then we use Badger. We pass the path to that SQL file, and it passes that. It finds all of the routines to declare. It exports them, and then we have them available. And we can just call, okay, add skyscraper. We pass in the database handle. We pass in the arguments, and it does the right thing. So let's have a little look at that in the context of my application. So here I have a SQL file where I've started writing out some of the various queries that go with my leftover app. Here I have register building. It takes the address and does an insert of it. That might conflict because there's a unique constraint on that, and we say, well, do nothing. It's okay if the user just missed the address in the dialog. And then here we say, well, to get the building by address. In this case, I want to return an object. And the object will be constructed based upon the field names, which we passed in as named arguments. Here is the class with the ID, the address. And I need to get that in scope. So I have a use here just to pull in the module where that is located. So even if these are lexical exports, it will do the right thing. And then here I have one to get a building just by an ID. Here I can get all the buildings. So the dollar here means that I'm expecting just a single result back out of this query. And the at means that I'm expecting a bunch of others. And there's, if you don't type it with an object, then you get a hash back or hashes back and things like that. So this is the SQL file. And then I've created a leftover database class. I'm using Badger here. I'm pulling my SQL in and getting those declarations made for me. I've also moved the migration logic into this file just so that we don't clutter up the service file with it. So we just make an instance we call migrate, and then that is being passed also here into the roots. So the root's able to query the database. And this is the normal sort of dependency injection pattern used in Crow, so you can write root tests if you want that don't really hit the database. So here, by the way, that is why it's an object, and I'm not just using the functions directly, but that could also work. So here we have the database handle. We just pass it down to each of these functions, wrapping them up. So here we register the building, and then we look it up here and hand back that object. And this gets all of the buildings. This gets a single building by the ID. So these are just a few of the methods that I need. And then over in my Crow roots, then I'm receiving this database handle. In my index, the start page, then we'll display a list of the buildings that are available. And if somebody wants to add a new building, I'm using the Crow Web App form module just to have a very simple form here. Actually, it's one field. And a post of that takes the form data, extracts the address, and adds the building, and then does a redirect. And then in either case, with the user selecting a building or by adding a new one, we end up at this /building/ whatever root, and we get the building and render this other template. So all relatively straightforward things. And then over here, I have my templates. So let me run this. So we get a fresh database set up. Postgres is started. Now we will start this application. 2 migrations are applied, and now the application is listening. And if we open this, you can see I am in deep tab debt here in my browser. So we don't have any locations yet, but let's put in this. I think okay, and it takes me to building 1. We can go back. Maybe let's add another. Oh, that's where the Edument office is in Prague. Okay, and then yeah, that's it. We can select those, and it is working. So by now I have a database, I have a way to sort out the schema with migrations, I have a way to write queries against it, but what about testing? So I wrote a module for this called Test Containerized Service. It's actually based upon Dev Containerized Service, which is kind of nice because it means that every time that we add support for a different kind of database in Dev Containerized Service, then magically it just will work once released in Test Containerized Service as well. So we can mock the database in tests. That's quite a common thing to do. But database queries can be quite complex. There's plenty to go wrong in them. So it can be nice to be able to have tests that work against the database too. But the setup work for them can be a little bit annoying to do. And so often, I mean, I have things I work on where I kind of realize that I don't really run the database tests. I kind of just cross fingers and then sort of push to CI where they run for me and fix things up that way if I get it wrong, just because it's a bit annoying to get it set up. So I thought, well, that's not good. So what can I do about my laziness? And the answer is, of course, write a module that lets me be lazy and still run the tests. So this is the module I wrote, Test Containerized Service. So here I use the dbpg, I use test, and then I use Test Containerized Service. And this test service call takes the name of the service that I want to have, in this case Postgres, a tag. So this is all looking very familiar maybe from the dev containerized service. And the main differences in here are simply that it's always throwaway. And if there is no Docker available or there's some other setup issue, for example, pulling the image failed, the test is just quietly skipped rather than it making problems. So this means that you can write such tests, and if you ship your module off and it runs on a machine without, say, Docker there, then that won't be a test failure. It'll just quietly say, no, we won't do this. So let's take a little look at that. So I've added another test file alongside the migration test. This is the database test, and I'm using the test containerized service module to get a connection string to a test database, a fresh, clean database that I can use for the tests. The first thing I need to do is to apply the migrations to the latest version. This is going to take it from nothing to the current state of the migrations. And with that done, then I'm ready to start testing my my various methods. So for example, we'll add 3 buildings. We can add one that's got a duplicate address, and if we remember that that's meant to be unique, so it shouldn't cause any problems if there's duplicate addresses in there. It'll just drop the insert quietly, and then we get the buildings, and we expect there to be 2 because it should be deduplicating, and then we can run these. So the migration one's complete almost instantly, and this one needs to set up a container, so it takes just a little bit longer, and one fails. Oh dear. So this it gives back 3 instead of 2. Okay, that's a slight surprise. So did I mess something up? Let's take a look in here. So we have building. Oh, I wanted a unique key on address, but it appears that I forgot to do so. So let's fix this. building should be unique by address. Okay, so there we are. And then we need to alter the table buildings. And we want to put a unique key on the column address. Okay, so migration tests run, so it's happy with this migration. There's no typos this time. And my database test passes now as well. So by now I have a way to get a local development database up and running. I have a way to migrate it to latest version of a bunch of changes. I have a nice way of writing SQL and calling it from my Raku code. And then I even can write tests. Surely I must be happy now. And the answer is, well, almost, but there's a few workflows that still are quite common, but not really handled. So for example, one of the things that often is needed when investigating problems with a bunch of database code is going and running the Postgres client and having a look in there and seeing what it is really in the database to have a look at the data. Also, it'd be perhaps nice if I didn't really have to start from scratch. I might enter some test data and then want to still have it around in the future when I come back to develop the system a bit further. So there's a few more things that Dev Containerized Service can do. By default, it gives a clean state every time. So there's nothing sort of persistent about it. It runs the container, all the storage is inside of the container is removed at exit, and that's it. But if we want to have a development database that sticks around, then it also knows how to put that as a named volume in Docker and leave it around so that we can later be able to take it and get that data back again and continue. So in order to do that, we need to do just two changes to this configuration file. The first one is that we need to give a project name, and that is just a way for it to namespace these volumes and any other configuration information that it will keep around. And then we say, please also store this. Store also takes the name of what I call the default store, which is the default sort of name to store those under, but the default, which is called default, is normally fine. So let me go back to my leftover app for the last time and show you a quick demo of some of these features. So here in my development environment file, I've specified the project name, the leftover, and then said that I want to have this Postgres service be stored persistently between different runs of my development environment. So let's try this out. So we'll take the script, we'll run the crow runner. And this is the first time, so it will bring up a fresh Postgres instance, and then it will start the system up and apply all the migrations, up to 3 of them there. So if I just open this, let's make one entry into this application, and then we can close that. Okay, and back over here, let's bring this down, start it up again, and it will look a little bit different because it says that there's already a data directory here, so we don't need to reinitialize it. There's no migrations to apply, and indeed, if I open this up again, then it's still there, which is good. The other thing that this opens the door to is a few other tools. So if I was, for example, to just tell it to show me this environment, then it has also saved this information about it here. This could be useful if I want to use some kind of database exploration tool in order to connect to this development database and have a look at what's in there. And a really common tool to use is the Postgres client. And the way that the Dev Containerized Service module is built is that it's possible to declare tools for different services, and I've declared the client tool for Postgres, and this looks like it does almost nothing. It's actually doing a little bit behind the scenes. It's taking this information, it's figuring out how to inject it to have the the Postgres client come up, but it's also using the PSQL client version that is inside of the container. So if you don't have it installed on your local machine, or if you have a different version and then there's some incompatibility with the server, definitely recently there's some issues that I sometimes run into with authentication methods with Postgres versions if the server and the client on the machine are different. So it avoids that, and then I can go and start having a look at what is in the database. So that is pretty convenient. The other thing that we can do is for any of these commands, the run, the tool, the show, it's possible to pass a store argument and say, no, I want to have these stored differently. And if I say store fresh, then it's going to bring up a fresh database instance. It'll leave the volumes for the previous one alone, and you can see it's applied the free migrations again. And I can go in to this application. It's an empty instance. Let's put in a different address just to demonstrate this. And then I can bring that back down. We can go back to the default store without mentioning one. And up it comes. And this time it's no migrations applied. We can open it, and it's the first set of data we had. So if I'm hunting a very particular problem, or want to maybe create an instance and apply data from some pulled from some production instance I need to debug or something like that, then I can create environments for being able to do that bit of debugging, and then we have this convenient way to run the Postgres client as well. So with all of that, I'm a little bit happier with the database workflow that I have when I'm building applications in Raku. All of this is very much focused on what I'm using, which means that it supports Postgres and not much else. I did a Redis configuration as well for the dev containerized service, and it's also supported for test containerized service. If you're using something else, all of these are very extensible, so you can send a pull request adding maybe MariaDB or whatever else it is that you are using and want to have supported in these tools. Obviously, that's rather a lot more work for DB migration declare to do a database support. There's already a base role with all the things to implement in it, but for writing these service specifications, it's a little bit easier. So do you have any questions? Well, unfortunately, Raku Conference this year collides with my vacation. So at the time you're listening to this, then assuming you're watching live, then I'm probably either on a mountain trail or in a pub on a mountain trail. So I can't take any questions right now. I did realize that earlier I did say that I would tell you why Badger is called Badger. And so maybe that is a question. And the answer is absolutely terrible. So if you have never seen the animation Badger, Badger, Badger before, just go and search for it. And there's a character in that animation, which I probably spent a lot too much time watching at university. That is a snake. And I used to work in Sweden, and the Swedish word for snake is orm, spelled O-R-M, as in object relational mapper. So Badger is not an O-R-M, and that is the name. So thank you very much for your attention. And this is how you can hunt me down. And I'm probably enjoying vacation if you're doing this right now, live during the conference, but I'll endeavor to get back to you after I return. And all of these modules are published on the Zev ecosystem, so you can take them, play with them, and I hope that this will be as useful to you as I think it's going to be to me. So thank you. Goodbye.